Hello wonderful person, this is Anton, and in today's video we're going to be discussing gas giants and brown dwarfs, and specifically we're going to be talking about the differences between them. What exactly is a gas giant, or I guess, what is not a gas giant? What would be a brown dwarf? Anyway, let's talk about this, and welcome to What the Math. So we're currently around an object that I previously made a video about approximately 2 months ago, and this was officially known as one of the biggest planets out there, one of the most massive planets out there, known as HR 2562b. This particular object is about 30 times the mass of our own gas giant Jupiter. Basically, it has approximately 30 Jupiters inside of it, but in terms of size, it's not very big. But is this actually a planet, or is this what would be known as a brown dwarf? So we're going to be discussing a few different ideas today, and specifically a lot of them are based on a relatively recent study from Johns Hopkins University by Dr. Luhman, assistant professor at Johns Hopkins Department of Physics, who basically tried to redefine how we think about planets and how we think about brown dwarfs. And to do this, well, let's just actually start by taking a look at what exactly this is. So this is a very massive object orbiting a star right there. And the star here is basically about 1.3 masses of our own sun. And this here is, it's kind of a, I guess, planetary object. And this is what the orbit looks like around this particular star. So in this sense, it does look like this is actually a planet. But based on the mass alone, this would not qualify as a planet. As a matter of fact, we currently believe that anything over about 10 masses of Jupiter should be qualified as a brown dwarf. Now, let's go back to our planet Earth for a second. And I'm going to show you one of the closest objects we discovered, relatively close to our own solar system, at a distance of about 6.5 light years away from us. There's actually an object that we discovered, I think in the last 5 years or so, and it's actually two objects. They're called Luhman 16. These two are classified as brown dwarfs, and they're right there. You can't really see them because they're not really that bright, but we're going to go and check them out. And these two brown dwarfs, or I guess this binary brown dwarf, are in a sense really similar to what you just saw, the planet that I just showed you a few seconds ago. Now, this is what this binary system looks like, and let's actually just zoom in closer to one of these objects, just so I can show you how it's actually not that much different from the planet you saw. It is about maybe twice the mass of that object, but in terms of pretty much everything else, or at least in terms of visual appearance, it's not going to be particularly different. So even though it does look bright right now, it's actually more gas giant looking than you would imagine. So by definition today, we think that brown dwarfs are very similar to gas giants. They're just a little bit more massive. They don't have any nuclear reaction on the inside, although they are actually capable of merging certain elements. Like, for example, there is a deuterium fusion and lithium fusion inside, which produces some energy. And for all sort of definition purposes, they are basically just really massive gas giants. They're kind of like failed stars that never had enough mass to become stars. Although if you were to combine both Luhman objects, they would definitely produce the next stage here, which would be a red dwarf. Now, what is interesting though is that there's definitely something else going on here, which basically makes this a brown dwarf and makes the previous object a planet. And what exactly is it? Well, it seems that the mass alone is not enough to define if it's a brown dwarf or if it's a planet. In other words, we're going to go back to the drawing board and try to redefine what a planet is. It's basically kind of like a Pluto debate all over again, but this time we're basically are trying to redefine what exactly is a planet, in terms of gas giants at least, and whether this is a planet. In other words, if a gas giant qualifies as a planet, or if it's actually also brown dwarf. Well, long story short, this is definitely a planet, and the one you saw in the beginning was also a planet. And the reason I'm actually saying this pretty comfortably is because of one more parameter that we didn't really talk about. And this parameter is known as metallicity. I've actually discussed this concept in one of the previous videos, but basically it is the amount of non-hydrogen, non-helium components inside the planet. Now, for our solar system, what's inside Jupiter and what's inside our own sun is, in terms of at least proportions, relatively similar. They both have relatively similar amount of hydrogen and helium in comparison to other elements like oxygen, carbon, silicon, and so on. So there's a tiny amount of non-hydrogen helium on the inside, about 2%, and then the rest is hydrogen and helium. It's the same for pretty much most gas giants in our solar system. It's the same for our sun as well. And if you look at various objects out there in basically in the rest of the galaxy, you'll find that most stars have relatively similar proportion of elements to their planets. But that's not really the same for this object right here, which is Luhman 16. This object doesn't really have a parent star, and so in that sense, it doesn't really have any proportions to compare it to. Alright, so that's maybe not very clear in terms of defining things. So let's go back to the drawing board and take a look at an early star system that's about to be developed in this particular simulation. So here what we have is basically a ring orbiting around the central object, and this central object at some point will become a star. It's not a star yet, it's still not massive enough, but it is acquiring more and more mass. Now, within this system, within this ring, certain object will also accrete into little rocks. So let's actually maybe put one here in orbit just so we can demonstrate this. And so here's one right here. And this object will also start basically sucking up a lot of the matter in this vicinity. And if it actually acquires a lot of hydrogen and helium, will become a gas giant. Now, with time, this particular object may become similar to Jupiter. This is kind of the planetary development model we currently believe in, and it does make a lot of sense. But what's different between this particular object that might become Saturn or Jupiter or any other gas giant and the brown dwarf we witnessed a few minutes ago, known as Luhman 16, is this. Luhman 16 didn't go through this particular event. It actually didn't really have similar development because, in a sense, Luhman 16 is just like this object right here, but it never became a star. So this right here, and we can actually try to recreate these, I guess, and this right here, let's just change its mass to be a little bit closer to the other object. Here we go. So these two objects, by default, would actually become binary brown dwarfs because they're not really planets. They weren't made in the same way as a planet was. They literally were created from the gravitational collapse. They were made at the center of their accretion disk, and they weren't really made as planets would be made by orbiting around a central star. So their actual metallicity and their structure and their composition might be actually very different from each other, and at the same time is going to be very different from any kind of a star they might be orbiting with or around. So in other words, both of these objects are basically not really planets because they weren't really created in the same way. Their actual origin plays a huge role in defining them as planets. And because these two objects were made more like stars and not like a typical planet would be made, this is why we can't really call them planets. And this is why we can't even call them stars. They're in their own sort of category of, I guess, not fully developed stars, or I guess you could call them failed stars. And their composition and metallicity plays a big role in basically describing them as such objects. So in some sense, the object we saw in the beginning, HR2562b, is technically a planet, or maybe it's actually in its own category of supermassive gas giants that are not really brown dwarfs, but are not even gas giants either. In other words, our neighbors Luhman 16, Luhman 16a, and Luhman 16b are definitely brown dwarfs. They're not large gas giants. They're not planets by any means or by any definition, because they were made like stars. And in that sense, they're actually very, very interesting for us because they might have their own planetary systems around them, and their planets might be completely different from what we might imagine. As a matter of fact, we are almost certain that most of these objects would have planetary systems, although Luhman 16A and B might be a little bit different since they are a binary system. It will be very difficult for them to maintain a stable planetary system. But a brown dwarf that doesn't have any companions, doesn't have any stars it orbits with, might actually have a fully developed planetary system, possibly with some planets that might even have enough atmosphere and some kind of a warm environment, but obviously not a lot of light because these objects are very, very dark. As a matter of fact, even though we call them brown dwarfs, they're technically actually more magenta in color. This is not super realistic. They're actually probably a little bit more this sort of color. And they are relatively dark, but they do produce some heat from inside that can actually be used to warm up objects orbiting around them. So they are very, very interesting objects. They're definitely not something that we normally think about, and there's a lot of them out there. As a matter of fact, if you were to just look at a typical patch of a night sky, if you were to just kind of like pick a square and look at some of the stars there, there's actually probably a lot more brown dwarfs in that patch of sky that you choose than there are actual stars. Brown dwarfs are very, very common. There's a lot of them out there, and we only very recently started discovering them because they're so dark. They're so difficult to see. You can only detect them with an infrared telescope. So maybe in the next few years we'll find more of them out there, maybe even some of them much closer to us than we believe. And we might even be able to find some of them that have really comfortable, habitable planets that we can one day call home. For now though, that's all I wanted to talk about. I wanted to basically explain how brown dwarfs are different from planets and how they were created completely different as well. Thank you so much for watching. Please subscribe if you still haven't, share this video with someone who enjoys watching space videos, and I'll see you guys tomorrow. Space out, and as always, bye bye.